Hello and welcome to the second part of this video. I'm going to try narrating this one for once to see if it makes it any easier to make videos so I can upload more often. I'll try and subtitle it in YouTube so it's still accessible without audio, but that might take a while because I don't know what I'm doing. Anyways, yes, in the second part of this video I want to talk about more of the navigation-y based projects that weren't so successful. Lots of the code I've written is about stuff that isn't quite pathfinding in the style of sucker pinches, harder drives, or 30 weird test algorithms. I suspect that lots of these algorithms already exist, and I just don't know the name of them. So if you do know the name of any of these algorithms, please post them in the comments. Thank you. So, before we get started, I need to introduce A-star. A-star is probably the most common technique for pathfinding in video games. It's fast, you can use it in lots of scenarios, and I've used it a lot before because it's a great algorithm. However, it has one massive downside. You need a navigation mesh, and I'm too lazy to build a navigation mesh. Also, it's not great if the level is very dynamic because you need to update the navigation mesh frequently. That could be quite expensive. Also, it's really boring, and I want to write some strange code. I'm not going to explain how A-star works in this video, because there's lots of other videos that explain it much better than I do, so you should go watch them. I started working on a lot of this code because, to be quite honest, the ground AI in VTOL, it's a bit disappointing. It doesn't react to any threats other than shooting at them. It can't, like, move away from an enemy, it can't move towards an enemy. It just does exactly what the level editor commanded them to do. Personally, I think this is quite boring. It doesn't make them very reactive when you're playing against them. So, I was going to make them better. And then I didn't do that because I got bored of working on it. Now, the tanks in VTOL, by default, they don't come with pathfinding, so the level editor has to explicitly say where the tanks are going to drive. Now, that's not great if we want the enemy to direct threats. So what we have to do is we have to develop our own pathfinding algorithm. Anyways, here's my first attempt at a not quite pathfinding algorithm. This is a random line thing. I don't have a name for it, but basically what it does is it picks a midpoint between the start and the destination, and then it picks a midpoint between the 2 points it just generated, and it keeps going on recursively until eventually the segments are short enough that it's happy with it. And yeah, it samples a bunch of random points, and then it picks ones that are preferably flat and don't go in the water. As you can see, it does a reasonable job. I don't actually think this pathfinding's that bad. It does generate really wiggly paths, but I think that's quite charming. Obviously, it is completely useless when it comes to actually navigating around like an obstacle, such as a wall or a river. It just sort of wiggles its way through the path of least resistance. Maybe it could be useful for some sort of bug or like animal type AI creature. It is annoyingly very, very slow. Obviously it uses a lot of raycasts, which isn't great for performance. You could probably try changing the number of raycasts that are allowed to be performed per frame, but still, you know, it's eventually going to be a bottleneck regardless. You can also try optimizing the midpoints after you place them, which it smooths out the path a bit, but it doesn't actually help with like the root problem of getting around obstacles. I did actually implement this into the game, which was quite fun. It has these cubes so you can visualize the path. It is actually fairly decent for the tanks, because it'll generate a fairly wiggly path across the map. There's not many obstacles in the way in VTOL VR for ground vehicles, so most of the time, it's a pretty decent path. Unfortunately, at some point while updating random encounters, all the ground vehicles now get krakened into the void whenever you move around. I'm not sure what causes it, and yeah, so I can't actually use this. Fortunately, though, the ships don't get krakened, which is great fun. However, it does seem that the train collision gets turned off when you're very, very far away, which means that most of the paths end up clipping through mountains in the distance, which is quite disappointing. The game has been updated since then, so maybe it'll work again. It's time for Weird Pathfinding Technique 2, Flow Field Pathfinding. This one is actually a pathfinding technique, I lied to you. Essentially how it works is you just generate a grid of squares, and then each square has like a distance to the destination node, and then you just create a gradient, and you follow the gradient down. It's pretty simple. I wrote this one, was then immediately underwhelmed by how average it was. In order to combat its averageness, I added a shite ton of red physics balls, which is really fun. Here's around 1,000 physics spheres, and yeah, they just follow the gradient down to the destination node, and then when they get to the end, they're teleported somewhere random. This is super satisfying to watch, but I'm not actually sure it's that useful for game AI. It's pretty rare that you need like this many units to all path to the same location. Maybe I thought I was gonna have like swarms of Russian tanks you know, entering Germany. All the balls rolling around tend to look like some sort of migratory animal. It's quite fun. I did try adding more physics warps. This is about 2,500, and as you can see, the frame rate is bad. As I've discovered from a lot of these techniques, the bottleneck usually isn't actually the pathfinding algorithm itself, it's usually the physics of following these paths. Speaking of physics, let's talk about VTOL VR again. The physics of the ground units in VTOL VR are pretty simple, because, you know, it's a flight simulator, they're not like the core focus of the game. However, they are very primitive. Vehicles that stop at the destination will just come to an immediate and abrupt stop, which is a bit strange. I mean, we don't have to go crazy and write a track simulation here, but it would be nice to have a little bit of physics. This is using the same, what was it called, flow field pathfinding algorithm as before. However, now, instead of using a physics orb, it's using a hovercraft. Oh yeah, baby! That's what we've all been waiting for! But yes, essentially, I've written my own basic physics simulation for these hovercrafts. It runs 10 times a second, and the motion between these 10 times a second is interpolated, which means it looks very smooth, and you can't tell that it's only running at 10 frames per second. The performance of these is what I would describe as very good, considering that every time I try to apply a more complex model to it, the rendering causes bottlenecks before the physics does, which is great! I might need to look at my render settings. It doesn't just do hovercrafts as well. By tweaking the collision rules a bit, you can get it to behave like tanks or cars, depending on whichever you most fancy. Anyway, we finally returned to the tried and tested A-star pathfinding algorithm. In the end, I bit the billet and I raycrafted a grid of points on the terrain, and I used that to generate a navigation mesh, and then I wrote an A-star pathfinding algorithm, and I threaded it, and it's really, really, really fast! Unless I've screwed up my debug code, it does about 60,000 paths per second, which is way more than I need. And the additional benefit of it being on a separate thread means that it won't slow the game down, even if it does take several years to generate a single path for whatever reason. The end result, I'm left with this cool demonstration about 1,000 pathfinding cars, which consistently stays above 140 frames a second, which is very nice, because that's the limit of my monitor. I think I managed to get it up to 4,000 cars at, like, above 60 FPS, although I can't really remember very well, and I've also lost my footage for that, so you're gonna have to take my word for that. Even though I haven't implemented it into VTOL VR yet, I have still managed to find a use for this. Welcome to my very abstract logistics simulation! Here we can see England and Wales and some houses and some warehouses and some factories and yeah. So what happens is that these factories will produce resources, which are these red cubes, and houses will request resources, which are also red cubes. I imagine, in my mind, the different colours of the cubes represent like different types of resources, like electronics, or I don't know what else other people order on Amazon. There's these logistical warehouses which temporarily store the resources, and then a truck will be dispatched from a logistics warehouse to a normal house and deliver the delivery. If I had more time, maybe I would add like airports or the trains that I made earlier or some other stuff, but ran out of time. So this is still pretty good though. And now the final navigation experiment I made. Subgoal type beat. I programmed a thing like this before in 2D for a boat, which was quite fun, but I've always wanted to try in 3D with some sort of VTOL aircraft. I couldn't actually bother to model a VTOL aircraft, so I just reused the Heinz flight model from the AI first-person shooter I made. Essentially how this works is if there isn't a direct line of sight to the target, the helicopter will shoot out a bunch of raycasts in a very unscientific manner. It'll fly towards the point that's closest towards the destination goal. When it gets to its sub-goal, it'll just repeat the process again until eventually it reaches the destination. Pretty simple technique, but I think it's one of the more useful ones that isn't just A-star pathfinding. A-star pathfinding isn't super useful in a scenario like this, because generally in most video games the sky tends to be infinitely large, and it's quite hard to generate a nav mesh for an infinitely large sky. Obviously, if you had some sort of underground cave network, this technique would be less useful. So yes, that concludes my adventures in things that aren't quite A-star pathfinding. And also A-star pathfinding. If you haven't written any A-star pathfinding algorithms before, go do it. It's good fun. If you have written A-star pathfinding before, go write some strange code. It won't be useful, but it'll be fun. This is the end of the video now. Goodbye.